Hi everyone, welcome back to yet another Euphoria Academia YouTube video where we do past papers and we go through them step by step and we'll give you some tips and tricks to understand as well as complete the question. Today we're going to be doing the NSC Grade 12 Physical Sciences Paper 1 that was written in November 2022. My name is Ole and I'll be taking you through it. So let's get into it. Right, in today's paper, we're going to be covering everything with regard to electric circuits. So we're first going to start in the multiple choice questions, question 1.8, and the question reads as, we have the EMF of a battery and the internal resistance is also given. The battery is connected to 3 resistors, 4 voltmeters, and the resistance on the conducting wires is non-existent, while the voltmeters have a very high resistance. That is very important, right? Very high resistance. That is why we connect voltmeters in parallel and not in series. Just an FYI. So the question asks, which one of the following equations represents the reading on voltmeter V1 in terms of the readings on the other voltmeters? All right, so what we're going to find is V1, which reads essentially the potential difference across the whole circuit, right? That is what it's reading. So V1 is the whole circuit, and we're meant to find the equivalent, which of the following equation represents the reading on V1. So how are we going to find V1? So V1 essentially measures the potential drop in this whole circuit. So when we get to a resistor in series, there's going to be a voltage drop. When we get to this whole parallel circuit, we're going to also get a voltage drop. All right. So the answer that we are going to find, or the equation, right, has V1. So what is V1 equal to? We know that it's equal to potential drop, so we're going to find that it's equal to the potential drop of V2 plus V3. Now, why would it just be V3 and not V4? Well, the potential difference across V3 and V4 is actually the same because we have a parallel circuit. So even if the answer set had V4, we could even have written V4. So this is the equation of V1, and our answer is number A. Now, the main part of the question paper that we're going to be doing is question 8 that has to do with electric circuits. So in this question 8, we have it starting from 8.1 all the way up until 8.5. All right, I'm not going to do any AC questions today because in this question paper, it's quite easy to follow through. If you want me to do it, please comment down and we can do a revisit, of course. All right, so the question, all of it for question 8 is out of 20 marks. So without further ado, let us get into it. Let's start with the first bit of question 8, and that is understanding what is going on in the circuit that we have. Right, so the circuit diagram below shows 4 resistors connected to a battery of EMF epsilon. We don't know our EMF and internal resistance R. We are not given that as well. The resistance on of the ammeter and the connecting wires are negligible, while the voltmeters have very high resistances. There we have it again. So like we said, that's why we put voltmeters in parallel, because they have such a high resistance, right? If you put them in series, hey, you're gonna get a very high voltage drop across it, right? So let us understand what is going on here. So we have a battery right here, and if you follow conventional flow, the current is going to flow from the positive terminal. It will go through this ammeter. We're given an ammeter reading, so that A is actually the total resistance. That 3.5 amps is the total, not resistance, total current through the circuit. The current will flow through there, and then it will go into this branch over here through the 1 ohm resistor. Now, something interesting is going to happen here, but regardless, so it's going to split. Let's keep on going in that direction, and it's going to get into this circuit, go through the 3 ohm resistor. Now, notice that the 2 ohm resistor is actually in series to this 3 ohm resistor, and then the current is going to rejoin here. So our parallel circuit for this guy over here, we actually have that will be our 3 ohm resistor, and that will be our 2 ohm resistor connected like that. All right, and then in the other branch, we're going to have our 1 ohm resistor connected. So that will be our parallel circuit, and then we have this 4 ohm resistor in series. So that's effectively what we have. This is our equivalent circuit with the resistors in series like that. All right, now this voltmeter reads the potential drop across this circuit. So the last circuit, the circuit including the resistor 3 and the resistor 2. Alright, that's what the voltmeter 2 is reading, and we're going to go through the 4 ohm resistor, and then the current is finally back to the negative terminal of the battery. So now that we understand what is going on, we can start with the question. Now, question 8.1 asks us to state Ohm's law in words. I'm not going to write the definition, but just know that you need to include a couple of keywords. So you need to mention the potential difference across a conductor that will be directly proportional to the current through the conductor and at a constant temperature. All right, this is just me summarizing essentially what this thing is, and you should have your marks, but just go through all your definitions when you write these papers. Right, now we are told that switch S is closed, right? And the reading on the ammeter is that 3.5 amps. And question 8.2.1 is asking us to calculate the total external resistance in this circuit. So our R external is made up of our parallel circuit resistance plus the series resistance that we have through the 4 ohm resistance. Now, our parallel resistance is going to be equal to our R1 multiplied to our R2 and 3, right? And that will be over our R1 plus the resistance of resistor 2 as well as the resistance of number 3. All right, so how we do that, so essentially our resistance of 2,3 is equal to our 3 ohm plus our 2 ohm, and that is going to give us 5 ohms. Remember, we said that the 3 ohm resistor and the 2 ohm resistor are actually in series with each other, but they're part of that parallel circuit. All right, so let us just do the substitutions. We have 1 ohms, that will be multiplied to 5 ohms, and at the bottom there we have 1 ohm plus our 5 ohm. Now our resistance through this parallel circuit is equal to 0.83 ohms, but that's not our total external resistance. Our R external, as stated before, is equal to our parallel resistance plus our series resistance. So our parallel is equal to 0.83 ohms plus our series resistance of 4 ohms, and that is going to give us a total of 4.83 ohms. Alright, for question 8.2.2, we're asked to calculate the reading on voltmeter V1. Now, voltmeter V1 reads the potential difference across the whole circuit. So there's going to be a difference. We're going to have a high potential difference here, our high voltage, a high V, and then here we're going to have a low V after it has gone through the whole circuit of potential dips and drops and dips and drops and all that. That is going to be read by V1. So that potential difference is going to be read by V1. So we can actually calculate that, because this V1 does not account for the internal resistance of the resistor, so we don't need it. But we do have the total external resistance as 4.83 ohms, and then we have our current. The current that we're given was the current across or through the whole circuit, that was given to us as 3.5 amps, right? And we can just use our Ohm's law, which, well, if you write it in a different way, but we know that our voltage will be equal to our current multiplied to our resistance, and we're just going to substitute 3.5 multiplied to our 4.83. That is going to give us an answer of my mistake, apologies, it's going to give us an answer of 16.91 volts. Alright, the next question asks us, this question 8.2.3, it asks us, how does the reading on voltmeter V2 compare to the reading of the voltmeter V1? Choose from smaller than, equal to, or greater than. Well, from the gates, I'll just tell you that it is smaller than. Alright. Now, in the previous question, we said what V1 is measuring, right? So it's across the whole circuit, right? So that potential difference is going to be higher than the potential difference at V2, because what essentially is happening is it moves from the positive terminal, okay, that doesn't have resistance, then we have a split, but in the split we're going to have the current go through here, and then we're going to get a voltage drop through there, and then it rejoins there, and then through here we're going to get a voltage drop, and then through here we're going to get a voltage drop, and through that 4 ohm we're going to get another voltage drop. So essentially what V1 will be measuring, how many voltage drops? It's going to be measuring 1, 2, 3, 4 So it's going to be measuring 4 voltage drops. And then V2 will be measuring the voltage drop of 1, 2, right? So it's going to be measuring 2 voltage drops. And that is lower than this 4 voltage drop situation that we have there. That is why V2 is smaller, or will read a smaller value than V1. All right, question 8.3 starts with saying that a learner concludes that the EMF of the battery is equal to the reading on V1. Now, question 8.3.1 asks us to define the term EMF. So I'm not going to write it, but just write the definition. But understand that the EMF is the maximum amount of energy supplied by the battery per unit charge. So just know that you need to include certain keywords. So max amount of energy, and then per unit charge is also quite important. So let us move on to question 8.3.2. Question 8.3.2 asks us that the conclusion that the learner drew, if it's correct or not. Right? So the learner is not correct, and we shall explain in the next question, which asks us to explain our reasoning. So looking at this circuit, V1, as we said, it measures those 4 voltage drops, right? But the EMF of the battery is the maximum amount of energy the battery can supply. It does not mean that it is the total amount of energy that is going to be read or felt throughout the whole circuit. So this EMF value, this V1, yeah, the EMF value. Let's talk about that. The EMF value does not take into account the internal resistance of the battery, as well as some resistances in the circuit. So maybe the wires, there might be a faulty wire, or something might be getting hotter than it needs to, or whatever the case is. The EMF does not take account for all these things. But what V1 is measuring, V1 is actually measuring the voltage drops, and then it is taking into account the internal resistance. I'm just going to write small r, and then maybe other resistances that we might not know. So that's the difference, right? The EMF, it doesn't look at the internal resistance, but the V1 is looking at it for sure. It is considering it, it is taking it into account. All right, now the second part of question 8. Now it says that switch S is now removed and replaced by the voltmeter V2 as shown in the circuit diagram. All right, so we previously had a switch here, but now we have a voltmeter. And remember that the voltmeter has a very high resistance. Okay, that's quite important. All right, cool. So the next question, 8.4, asks us, how will the following change? We need to choose from increases, decreases, or remains the same. All right, so for question 8.4.1, it asks us the power dissipated by the 4 ohm resistor. Does it increase, decrease, or it remains the same? Well, it will decrease or decreases because essentially the voltage across it will decrease, right? But the current remains the same, and the formula power is equal to VI. We have that staying the same, so I'm just gonna write same. And then the voltage, that will decrease, and if that decreases, that means the power needs to decrease. I'll explain in question 8.5 why all of this is happening. All right. Now question 8.4.2, it asks us how will the reading on voltmeter V1 actually change? How will it change? Well, it will increase. It increases. Because now essentially, instead of it previously, you remember when we had a switch there, it read the voltage drops across the 4 resistors, so it had 4 voltage drops, right? And then now with an addition of the voltmeter, we have another voltage drop. So let me just write previously on, right? We now have 5 voltage drops, and if we have 5 voltage drops, if I'm measuring, I'm gonna have a high V here, and now my V, my voltage there, is gonna be lower than before, because now we have 5 voltage drops instead of the 4 that we had. So that would mean that the difference between these two potentials will be higher. Yeah, just like Thames, higher. Okay, question 8.5 asks us to explain our answer to question 8.4.2. All right, so essentially, with a voltmeter, right, you always connect it in parallel because it has a very high resistance. So let's just start there to start our little paragraph. So voltmeter has a high resistance, right? And it is connected in series. It is connected, in this case, it is connected in series, right? It is connected in series to the 1 ohm resistor. That essentially means that we still have a parallel circuit, mind you, right? That means if the resistance is high there, the current does not really want to flow through a high resistance. Electricity will always choose the path of less resistance. So that means that the current flowing through there, let's just call that I1, and let me select a different color. The current flowing through there, that we'll call I2. That I1 will be much higher than our I2, because as stated before, current will always move through a path of less resistance. All right, so that means that the current through I2 is current through I2 is little or no resistance no current at all is flowing through there, right? Because of that high resistance through the voltmeter. Now, what does that actually mean for V1? Why should V1 even care? All right, it means that because of the addition of the voltmeter, the total resistance of the circuit, right, will increase, right? And looking at our Ohm's law, maybe let me write it in terms of the current. I is equal to V over R, right? So if the R increases, the resistance increases, if that goes high with the potential difference, the total potential difference across the circuit remaining constant. If we have a high denominator, the answer that we're going to have is going to be lower, right? So the current is going to be much lower than we had previously. So the current will decrease through this circuit, all right? Which means the V1, which is all the voltage drops. So the external volts, right? Which is what V1 is reading. All of that will increase. External voltage will increase, right? While the internal voltage decreases. The internal voltage being the battery. But yeah, that's essentially it. So we're going to have, instead of 4, we're going to have 4 voltage drops compared to 4 voltage drops. But remember that the voltage drop across V2 will now be quite high, right? And that's our answer for 8.5, and that concludes our question 8. Please comment down below if you have any questions. This was a lot of theory and understanding, so I don't mind going through another video, another example like this.